What is the graph of one cycle of a sine curve with amplitude 3, period 4 pi, and a greater than 0? What is the equation for the sine curve? So, again, this is section 13.4. Drawing our axes here. Amplitude of 3 is our height away from, our distance away from 0. So 3 above, 3 below. A is greater than 0 means there's no reflection, so we're going to go up right away. And a period of 4 pi, that's how long it's going to take for one cycle. So I'm going to mark this whole thing as 4 pi and then split it up. So I take 4 pi divided by 4 sections. Again, remember we have the 5 points, 0, max, 0, min, 0. So I need to split it into 4 pieces, which means pi. So each one of these marks is going to be a pi. 1 pi, 2 pi, 3 pi, 4 pi. Now, since it's sine, I go 0, max, 0, min, 0. Connect my dots, and this continues in both directions. What is the equation for the sine curve? A times sine of b to the x power. Our a value is our amplitude. Here it's a 3 and positive. B, to find b, we take 2 pi divided by b equals our period. So I'm going to multiply by b on both sides. Go ahead and divide by 4 pi to get b by itself. 2 over 4 is the same as 1/2, so b equals 1/2. The book might do a theta here instead of an x. Either way works for me. Graphing from a function rule. What is the graph of one cycle of y equals 1/2 sine of 2 theta? So, 1/2 is our a value. So we have an amplitude of a half, and it's positive, so we go up first. The 2 is our b value. So for that, we take 2 pi divided by b to get our period. 2 pi divided by 2 is pi. So, again, we didn't have any vertical shifts. So, amplitude is half. Guys, you can sure change that if you want to and make them still by ones, but it's a lot easier if you just change your scales when we're dealing with trig here. 4 spots because we have those 5 points. Make sure they're all equidistant, so I have 3 boxes in between. Again, I don't really know why I picked that. I think it's because it's easier to translate, but that's just kind of how I've always done it. Our period's going to be pi. So I take it and split it into 4 pieces. So each of these is going to be a pi over 4. And then I have 2 pi over 4, which simplifies to pi over 2. Then I have 3 pi over 4, and then 4 pi over 4, which simplifies to just pi. Since it's positive, we're going to go 0, max, 0, min, 0. Again, it should be curvy. Mine's a little bit boxy. The ones in the book are a little bit better. A here is 1.5, so we're going to go up. That's our amplitude. Our B is 2. So we're going to take 2 pi divided by B, just 2 pi divided by 2, which is pi. And this is our period of our function. So graph of one cycle. So I guess I don't need the arrows, sorry. Pi. I'm going to split it into fourths again. So pi over 4, just like on the last one, 2 pi over 4 is pi over 2, 3 pi over 4, and 4 pi over 4. My a value is 1.5. And since it's positive, we're going to go up. 0, max, 0, min, 0. And 1 cycle. So I don't need the arrow there when it says 1 cycle. Okay, same idea here. Our a is going to be 3. It's positive, so we're going up first. Our b value is pi over 2. So I take 2 pi divided by pi over 2. We're going to take 2 pi times 2 over pi. We multiply by the reciprocal, so I flip this one upside down. Pi's cancel, and I just get 4. So the period here is 4. I know that's a little weird because we've been dealing with pi, but we're going to make it work. It doesn't really matter as long as we label it. So we said that our amplitude is 3. Again, same distance both ways. Mark off my 4 places because I have 0 max, 0 min, 0. 4 is the period, so I'm going to split these into 4 pieces. Here's just going to be 1, 2, 3, 4. 4 equal pieces. 4 divided by 4 is just a 1, so 1, 2, 3, 4. That's a bad color. 0, max, 0, min, 0. We're going to use the graph on the top of page 855 to model waves of red, blue, and yellow light. What equation models blue light? So if we look here at blue light, okay, we can tell that it's a sine function because it starts at 0 and one cycle ends at 480 if we look at the blue. So our period is 480, which means we can find our b value. We take 2 pi divided by b equals our period. Multiply by b. Divide. And we get pi over 240 equals b. If we look there as well, our amplitude, or our distance away from 0, our maximum point is at 1, and our minimum point is at -1, so it's 1 both ways. So we have y equals a sine of bx. A is 1. We said b is pi over 240, and either x or theta, I think is what the book has. So we'll go with theta there. So y equals sine of pi over 240 theta, and that is letter D. Now, using the same graph on the top of page 855, what equation models the red light? If we look there, red light, one cycle, so 0 max, 0 min, back to 0, ends at 640. So the period is from 0 to 640, so 640. So to find our b, we take 2 pi divided by b equals our period. 2 pi divided by b equals 640. Go ahead and multiply by b on both sides and divide by 640. 2 pi over 640 equals b, which is pi over 320. Now, I'm going to plug that into y equals a sine of b theta or bx, either way. Depends on how your axis is labeled. Here it says our theta scale is in nanometers, so we're going to go with theta. And our amplitude again here is still 1. our distance away from our axis is 1, both our max and our minimum. So this is a 1. We don't have to put that in. But our b value is pi over 320 theta. As the terminal side of an angle rotates about the origin, beginning at 0 degrees, its sine value on the unit circle increases from 0 to 1, decreases from 1 to -1, and then increases back to 0. A non-translated sine function can be completely described in terms of its amplitude and period. And there is your assignment.